All right, so trying this again, y'all. This is test 4 review. And for question 1, we're doing a graph. And they want us to graph y equals 1/3 to the x. So, like I said, I'm going to graph this one on my calculator. I'm going to clear that. So, put in your 1/3 x. Now, you can use the alpha y equals, or you can just punch it in like a fraction using the parentheses. So, parentheses, I'm going to do 1 divided by 3. Close my parentheses, and then for my exponent, put in my x. All right, so we're just looking at the shape of this graph. So if you notice, it's going downhill, and it's doing a horizontal asymptote on that x-axis. So it does not cross the x-axis. So y'all, on this one, they had 4 pictures to look at. And if you look at my 4 pictures, I go with B on that. And okay, it comes down and then hugs that x-axis. Okay, watch out for D, because it does come down, but D goes below the x-axis. Okay, so we would definitely choose B on that one. All right, number 2 is another graph, but this is the one where we got to describe what moves happen to it. All right, y'all letting one in. So for number 2, they want us to graph f of x equals 2 to the x plus 3. So they'll ask you, this is where you had to fill in. It'll say start with the graph of y equals blank to the x. And then we'll tell what move it had. So for here, you want to put your base, which is our 2. Now, y'all don't put the x because they've already got the x in the answer blank, okay? So put in your 2, which is your base. And then we got to describe what's happening when we add 3 to the x. Well, remember, when you attack the x as an exponent, it's going to move me left or right. Since we're adding on this one, it's going to move us left 3 units. So this will say shift the graph left 3 units. Okay, so if they subtract, you're going right. They add, you're actually going left. Now, the trick to this one is graphing it in MATLAB. So the graph, this is where we had to choose the exponential tool. So choose the exponential tool and then click on graph. Once you click on the graph, it's going to open a box. Remember, with all the horizontal, vertical, and all that. On this one, since we're going left, we're going to pull the horizontal left to -3. Now that makes the move, and we only had the one move, but y'all, it's really important on this one. In the left corner on the bottom, there is a box that says base. By default, it's got the E here. We got to change it to the base we had in our problem, which was a 2. So once you change your base to a 2 and you've moved your horizontal over to -3, it's going to shift your graph and be done. But y'all remember, you got to change that base, okay? All righty, so let's start working some of these other problems. For number 3, this is a sort of like a word problem. And it's on Melissa's 6th birthday. So on her 6th birthday, Melissa gets a $3,000 CD that earns 4% interest. And it's compounded semi-annually. So it says, if this CD matures on her 16th birthday, how much money will be available? Okay, so she got it on her 6th birthday. It matures on her 16th birthday, and they want to know how much will be available. So this is when we use the formula A of T equaled P times 1 plus R divided by N, all raised to the N times T. Remember, A stood for the amount in the account at time T. P was your principal balance or your starting amount. R is our interest rate. N is the number of compounds. And then T was the time in years. So we know P. P for us was the 3,000 we started with. Then we got 1 plus. R is 4%. But remember, we got to turn 4% into a decimal form. So you got to move the decimal left twice, which will give us a 0.04. So that would be our R, 0.04. N is the number of compounds. So we got to figure out what semi-annually means. So remember, semi-annually means twice a year. So that means N would be 2. And then we put 2 up here also for the exponent. And then we got to figure out T, which is our time. So they said it matured on the 16th birthday, and she got it on her 6th birthday. So we would do what? 16 minus 6 would give us 10 years. So T will be 10. And y'all, at this point, I'm going to plug this into my calculator, and they want me to round this 2 decimal places. So let's go throw that in on our calculator and see what we get. So let me quit that screen. So we had 3,000. And then parentheses, 1 plus 0.04 divided by 2. Close the parentheses and then get ready for the exponent, which was 2 times 10. All right, so y'all, we're going to hit enter and round this 2 decimal places. So that'd be $4,457. And let's see, 2 decimal places will be 84. And that's going to stay a 4 because it's got a 2 after it. So that'll be $4,457.84. Okay, so that was a trick on that, and just plugging everything into your formula and then punch it on your calculator and see what we get, okay? All right, now at number 4, we start finding logarithms. So they want us to find the logarithm. So y'all, for the first one, they got log base 10 of 100. So basically, they're looking for the exponent we would raise a 10 to turn it into a 100. So if you start with a 10, 10 times 10 is 100. So we had to multiply 10 twice. So that would give us an answer of 2. But y'all, let me show you another way. We got that calculator, remember? And on a calculator, we got log base. So if we hit math and arrow down through the options, you find log base. So hit enter on log base, put in your 10 for your base, arrow right and put in your 100 for that result. And y'all, when we hit enter, we get our 2. Okay, so either way, by hand or by calculator on that. All right, 5, find the log again. So there's going to be a few where we find a logarithm, okay? And remember, when you're finding a logarithm, you're basically finding exponents. So this one has the log base 3 of 3 to the 4th. Now this one, there was a property that we had that said if we have a base that matches the base of the result raised to an exponent, the answer was always the exponent. So anytime these match, your answer will be that exponent. So this will be a 4. But y'all, I'll show you. You can even punch that one on your calculator. And I'm going to use that log base again. So hit math, arrow down to log base, and enter. So I had a base of 3. And then I want to arrow right, and I had 3 to the 4th power. So that would be 3 exponent 4. All right, y'all, so it looks like my problem. I'm going to hit enter, and there you go. We get the answer of 4. All right, let me see. 6, find the logarithm again. So on 6, they got a log base 256 of a 4. Now, when your result is smaller than the base, you're going to get a fractional exponent, okay? So let's go punch that one in. So math, go down to log base, enter. So my base of the log is 256. Arrow right. That result was a 4. All right, y'all, watch this. When I hit enter, I'm going to get a 0.25, but we got to turn this into a fraction for the math lab. So to turn it into a fraction, you hit math, and then number 1's highlighted for fraction. So you just hit enter twice, and it turns that 0.25 into a 1/4. All right, let's see, number 7. Another one, it's a find a log. This one is a log base 40 of 1. Now, y'all, on this problem, I don't care what base is here. If that result is a 1, there's only one exponent that I can raise these numbers to create a 1. And that exponent would be 0. So remember, if that results a 1, then the exponent has to be a 0, okay? Remember, you could put that on log base also. Either way you want to go. Now, 8 and 9, on 8 and 9, they want to convert to a logarithmic equation. So we're going to convert to a logarithmic equation. So my exponential equation is 10 to the 4th equals 10,000. So we're going to convert this into a logarithmic equation. So we write log. The base of this log will equal the base of the exponential equation. So since 10 is the base, 10 will become the base of our log. The result is the 10,000 we got. And the exponent that would turn a 10 into a 10,000 is the 4. Okay, so you follow this pattern every time when you're going to convert from this exponential into this logarithmic. And so number 9 will do the same thing, y'all. Convert to a logarithmic equation. Now on this one, they're giving us e to the negative 3 equals r. So there's my exponential. So my log, I'm going to have to write log. The base of the log is the base of the exponential, which is the e. The result is the r. And that's going to equal the exponent of negative 3. Now, y'all, we'll say this, and you can write another way. So you could write it in MATLAB like that, or since this is a log base e, remember, log base e, I could write as the ln. Okay, so I could write a log base e as a ln and make this a ln of r equals negative 3. Either way on MATLAB, it'll take that answer, okay? All right, y'all, let's see. Next, we're going the other way. We're going to start with logs and rewrite them as exponential. So these will say convert to exponential equation. All right, so for number 10, I got log base 5 of 625 will equal 4. So notice if we're going the other way, our base is the 5. So remember, the base of the exponential will be the same as the base of the log. So my base is 5. My exponent is the 4. And 5 to the 4th equals the result of 625. So a lot of these problems you'll notice are just rewriting stuff, okay? So they gave us 2 of these also. So 11, we're going to convert to exponential. So y'all on this one, they're giving us letters instead of numbers, basically. I got a log base n of a capital T equals a negative y. Now, the one thing MATLAB is picky about are these letters. If they're capital letter, you got to use capital letter. If they're lowercase, you got to use lowercase in MATLAB, okay? All right, so let's write this one. The base will be the n. The exponent will be the negative y. And n to the negative y equals the result of RT. Okay, so remember on 8 and 9 and then 10 and 11, all we're doing is converting them into the other equations, okay? All right, y'all, let me see what I got next here. I'm gonna turn this paper over. It starts folding up on me. All right, so we're on number 12. So number 12 actually wants you to use a calculator. And we're going to approximate this 4 decimal places. Okay, so 4 decimal places. And what we're going to evaluate is ln of 910.8. So y'all, the only way to do this one is on the calculator using our ln button. So I'm going to go share my calculator. So let me clear all this off. So the ln is right on the calculator by the 4. So hit that ln button. Punch in 910.8. All right, so I got my 910.8 in. I'm going to now hit enter. So 4 decimal places, let's see, that'll be 6.81, 43, and that's going to stay at 3 because it's got a 2 after it. So 6.8143 on that one, okay? And really, that's the thing you got to worry about on this test. The biggest thing is getting that rounding, okay? Now, the next few are going to go back to the properties of the logarithms that were in section 9.4. We looked at the product rule, the power rule, and the quotient rule. So on 13, it wants us to express as a sum of logarithms. So this would come back to our product rule that said if we had a log of a product, we rewrote that as a sum of those logarithms. So y'all, my product will be log base 14 of 14 times 196. So to write it as a sum, I distribute the log 14 to both factors and put a plus sign in the middle of it. So we'll have a log base 14 of 14 plus a log base 14 of our 196. Now, all they wanted me to do is rewrite it as a sum, so I do not have to go any further. All right, 14 expressed as a product. So when you express as a product, that was using the power rule. And all I did on that power rule is I took the exponents and brought them down in front of the log. So y'all, I got a log base m of t to the 16th. And remember, we can't keep the exponents up here. So the the power rule said, bring the exponent down to the front and rewrite it as a product. So that'll give me 16 times the log base m of a t. And y'all, that's all you're doing when you're expressing these as a product. You're just bringing those exponents down, okay? All right, 15 said, write as sums or differences. So write as sums or differences of logs. All right, so let's see which one we're going to do. This is a log base C of parentheses x to the 6th, y to the 5th, and z. So since these are being multiplied, we'll be rewriting these as sums. Okay, we won't have any differences on this one. You only got differences when you had the quotients or stuff that was being divided, okay? So since these are being multiplied, this will be sums, just like we had up here on 13. So we're going to distribute log C to all three factors. So we get a log C of x to the 6th plus a log C of y to the 5th plus a log C of z. But y'all, if you remember, there's one more thing I gotta do to this answer. And that would be the ones with exponents. We got to do the power rule and bring those exponents down to the front. So this one would give me a 6 times the log C of x. Plus here, bringing the 5 down, you get a 5 log C of y. And then no exponent here, so that's going to stay a log C of our z. Okay, so just remember, you got to bring the exponents down on these to have the final answer, okay? All right, y'all, let's see. I'm going to let y'all catch up just a second there. So, y'all, any questions on these yet?
Not right now.
All righty, so let's keep going then. We'll get some tricky ones coming up. All right, so let me move this chat boxes. All right, so 16 is sort of like 15, except this one says express as sums and differences of logs. So remember, a while ago it said sums or differences. This one says sums and differences. So we're going to have both of those going on this one. So y'all got a log base B. Now I got a fraction coming up. I got a P4 Q6 over a M5 B8. Now y'all's problem for 16 will be exactly like mine. The only differences are going to be what exponents you have. But you will have a P and a Q on top and an M and a B on bottom. And it will be a base B like mine. The only difference, y'all, is going to be your exponents, okay? So now, here's the thing. The sums are going to come from the top two factors. So the top two factors will be positive. The bottom two factors will be the differences. These will both be subtracted, okay? And we're going to distribute to log B to all four of these factors. So the two on top, you're going to get a log B of P to the 4th plus a log B of Q to the 6th. So these two factors were on top. Notice they're both positive. Now I'm getting to the bottom. So both of those factors will be subtracted. So I'll have minus a log b of m to the fifth minus my log b of b to the eighth. So it's written as sums and differences. Now remember, on 3 of these, I'm going to bring the exponent down to the front. But y'all, this is a log b of b to the eighth. My base of my log matches the base raised to an exponent. So this whole thing at the end is going to equal that exponent. Just like that one where I did the log base 3 of 3 to the fourth earlier, gave us a 4. This one's just going to give us the 8. So bringing these first 3 exponents down, we get a 4 log b of p plus a 6 log b of q minus a 5 log b of m minus, remember we said all of this equaled 8. So y'all's answers will be exactly like mine, other than that 4, that 6, that 5, and that 8. All right, y'all. So let's see. 17 and 18 wanting us to simplify. So I got an ln of x squared plus 9x plus 20 minus ln of x plus 5. So the first thing you want to do is write this difference as a single logarithm. So remember, stuff being subtracted always went to the bottom. The stuff that was positive always went to the top. So bring out that ln. So we'll get a x squared plus 9x plus 20. That'll be on top. And on bottom will be the x plus 5. But y'all, this one will go further, because remember, they want me to simplify this. All I've done so far was rewrite it as a single logarithm. So to simplify this, since the top has an x squared in it, we need to factor that top. Now the bottom is just the x plus 5. There's nothing we can do to the x plus 5 on the bottom at the moment. So what we got to do is factor that top. And if we get an x plus 5 factor, we got to then cancel them. So y'all, here we go. We're going to factor the top, x and x. Last one's positive, so both of these will be positive. Factors of 20, that'll equal 9. Well, y'all, that's going to be what, a 5?
4.
And a 4. There you go. So on that one, you're going to cancel out that common factor. Now, y'all, this problem is very important that we keep that x plus 4 in parentheses when we write our answer. Because the ln has to affect everything. And if you don't put parentheses, MathLab will mark those wrong, okay? So you must keep parentheses. Okay? All right, 18 was another one where you had to simplify. So this time they're doing logs. I got a log of x squared minus 3x minus 10 minus a log of x squared minus 4. So we'll do this one like we did this one to start. We'll write this as a single log, and it's being subtracted again, so it's going to look like a quotient like we had over here. So you're going to bring out your log. So the x squared minus 3x minus 10 will go on top. And then this factor that was being subtracted, the x squared minus 4, goes to the bottom. Now, y'all, I will say this. The difference between 17 and 18, on 17, we only had to factor the top. On 18, you're going to have to factor the top and the bottom. So let's bring down our log. The top is going to factor into 2 parentheses. The bottom is going to factor into 2 parentheses. So let's work on the top first. I got an x and an x. The last number's negative, so you're going to have unlike signs no matter what. Now I need factors of 10. That'll give me a 3. So that'd be what, a 5 and 2, right? Now, remember, the larger number has to be negative like the middle. So make the 5 negative and the 2 positive. And if you add a 2 and a negative 5, that gives us that negative 3. Y'all, the bottom, that's perfect squares. Perfect squares always factor into conjugate pairs. One will be plus and one will be minus. And what goes in these 2 blanks is whatever the square root of that 4 is.
It'll be 2.
So that'd be a plus 2 and a minus 2. So y'all, you're going to get a perfect square there. It might be a 1. You put a 1 and a 1. A 4 was 2 and 2. 9 would be 3 and 3, and so on. But you know you're correct when you see that you got something that's going to cancel on this. So I'll cancel out the x plus 2's, and my final answer will be a log of a x minus 5 over x minus 2. Now, this one, since the answer was a fraction like this, we don't have to keep these parentheses, okay? Now, I don't think MathLab will mark it wrong if you keep the parentheses, but we do not need them on this answer because this whole fraction is being affected by that log, okay? All right, so remember 17 and 18 simplifying, just a lot of factoring on those ones. So y'all, now we got 1, 2, 3, we got about 5 or 6 equations to knock out now. And these will just say solved. So we'll start out with 3 exponential equations. Then we'll do, I think, about 3 logarithmic equations, okay? So for the first exponential, I got 2 to the 5x equals 8. So for your number 19, you're going to rewrite whatever number's on the right side using the same base as the left side. So how many 2's do you have to multiply to get an 8? Now, y'all, so there's my chat. It's lighting up, so let me see. So 3 of them, right? Perfect. Because 2 times 2 is 4, times 2 is 8. So rewrite this 8 as 2 to the 3rd power. Because on this one, notice, if I can rewrite them using the same base, that means the exponents have to be equal. Because both of these sides are actually equal, right? So since the bases match, the exponents equal each other. And then all we got to do now to solve for x, divide both sides by that 5. So y'all, those cancel, giving me my 1x. And nothing we can do to that. So that's going to stay at 3 over 5. So if you plug that 3 and 5 over here, the 5's cancel, and 2 to the third equals 8 is true. Now, 20 is also going to be exponential. But the difference in number 20 and number 19 is on number 20, I cannot rewrite this number using a base of 2. Because 2 to the first power is 2. If I multiply 2 times 2, I get 4. So no way to take a 2 and turn it into a 3. So when we weren't able to rewrite both sides using the same base, we took a log of both sides. So I'm going to take a log of 2 to the x is going to equal the log of our 3. Now, the only reason I wanted to use logs on this, because I have a log property that tells me that if I got exponents, I got to bring them exponents down to the front and rewrite it as a product. And that's the only way I can get the exponents down so that I can solve for them variables, y'all. So this would give me a x times log 2 equals or log 3. All right, there's only one more step to get this x by itself. So since the x is being multiplied by log 2, that means we need to divide both sides by the log 2. So my x times log 2 divided by log 2 will equal r log 3 divided by log 2. Notice these logs over here cancel, giving me my 1x. Now, since we got logs, we got to approximate this answer. And guess what? They want us to approximate it 4 decimal places. Now, y'all, when I do this one on the calculator, you got to close those parentheses on these logs, okay? All right, so let me go to my calculator, and we're going to estimate it 4 decimal places. So on top, I had a log of 3. I'm going to divide that by the log of 2. All right, now I'll go 4 decimal places. So I know that's what, a 1.58. Oh, look at that, y'all. I got a 49 with a 6 after that 9. So we got to round that up. But what's going to happen, that 49 is actually going to turn into a 50. So that I get a 1.5850. So since the 9 had to round up, that made the 4 have to round up also. All right, so like I said, 1.5850 on that one. Let's see, 21 said solve for t. So I got e to the negative 0.59 t equals 0.41. So this is exponential, but they threw the e at us on this one. Now, I do this one a little bit different than I did this one. Going to use the same process, but I'm not going to take a log of both sides. Since I got that e here, I'm going to take ln of both sides. So y'all, we got an ln of e to the negative 0.59t That's going to equal the ln of our 0.41. Now watch this. On the left side, ln is really a log base e. So I got a log base e of e to the negative 0.59t. Well, remember, when the base of the log matches the base raised to an exponent, the left side just becomes the exponent. So that's why we always use the ln when we got an e, because when you take the ln of e, the answer will be the exponent. So that's going to be negative 0.59t. That's going to equal the ln of 0.41. All right, now, so here's the thing. I'm solving it for the t, which is being multiplied by this. So we're going to divide both sides by the negative 0.59. So here we go. Negative 0.59t divided by negative 0.59. That'll equal our ln of 0.41 divided by negative 0.59. Now remember, when I do it on the calculator, I'm going to close those parentheses around that ln. And we're going to estimate this one 4 decimal places. So y'all, I'm going to pull that up on our calculator. So we got an ln 0.41. And like I said, close those parentheses. Then divide that by your negative 0.59. And remember, we're going 4 decimal places. So that's what, a 1.51. Oh, look at that. My fourth digit is a 1, but it's got an 8 after it. So this will be 1.5112. That third 1 is going to turn into a 2 because of that 8. All right, so those were the 3 exponential. The first one, you're going to rewrite using the same base. The second one, you're not going to be able to rewrite, so you're going to take logs and then solve that. The third one, you're not going to be able to rewrite, but instead of taking a log, since we got an e here, we're going to take ln's of both sides, okay? Now, the next 3 are going to be logarithmic equations. So we're still solving. This one has a log base 3 of 4x minus 9 equals 2. So y'all, when you got a single log like this equal to a number, the only thing we can do is rewrite this as exponential. So that's why we were doing them problems. I think it was what, 7, 8, 9, and 10 range, so that we could rewrite these. So remember, the base of the exponential is the base of the log, so that'll be 3. The exponent is the 2, and 3 squared has to equal 4x minus 9. So now we're going to solve that for x. So first thing is 3 squared. That'd be 3 times 3, which is 9. All right, so to solve that, y'all, I'm going to add 9 to both sides to get the 4x by itself. So I got 18 equal to our 4x. Then I'm going to divide both sides by 4. So those cancel, giving me my x. Now, MathLab takes this two ways. You can simplify this down, or you can get a decimal on this one. So for 22, MathLab will take a decimal or a fraction. So if you divide that, you get a 4.5. Or if you just reduced it, 18 over 4 reduces to a 9/2. So it will take 9/2 equal to x also. So y'all, either way on that one, okay? When you know you got to put a fraction under the answer blank, it'll actually say type of fraction, or integer or something like that. When it don't say nothing like that, it will take decimals, okay? All right, y'all, 23 is a log, and it's a longer one. It's got a log base 3 of b plus 16 minus a log base 3 of b plus 7. That's going to equal a log base 3 of a b. So I got logs everywhere, but my first step is on this left side. I got two logs, so I got to rewrite this as a single log. Now remember, just like those ones we simplified a while ago, if they're being subtracted, we'll rewrite it as a quotient. So that's going to give me log base 3. Remember, the b plus 16 goes to the top. This part that's being subtracted means that the b plus 7 goes to the bottom. And all of this is going to equal the log 3 of b on the right side. Now notice the difference up here. I had a log on one side and just a number. This one has a log on the left side and a log on the right side. And we had another property that said if the log base on one side equal the log base on the other side, that means that this result equals that result. So this b plus 16 over b plus 7 has to equal the b on the right side. So guess what? I always put a 1 under that. To solve this, I'm just going to cross multiply. To cross multiply, this b plus 16 is going to multiply by the 1. So b times 1 is b, plus 16 times 1 is 16. So that takes care of this side. Now the other side, I'm going to take this b plus 7 and multiply both of them times the b. So b times b gives us a b squared, plus 7 times b gives me a 7b. So y'all, what you got to be thinking now is you got a b squared term on this. So the only way to solve these kind of equations with the b squared is get everything on one side equal to 0. So I'm going to make this side 0 because my b squared's over here, and I want to keep it positive. So what I'll do is I'll subtract the b from both sides, and I'll subtract 16 from both sides. That way, b minus b is 0, 16 minus 16 is 0. So the left side is just a big 0. So over here, bring down the b squared. 7b minus the 1b left us 6b. And then bring down your negative 16. So now, since we're ready, we got a 0 here. Everything else is on the right side. We now get to factor that. So the b squared would be a b and a b. That's negative, so one will be positive, one will be negative. And let's see, factors of 16, that'll give me a 6. That's gonna be what
It would be -8 and 2.
But make that 8 positive for the moment.
Positive.
Because remember, the bigger number is gonna be positive like that middle number.
Yes, yes.
But now the two answers you get that you just said I'll get after I set both of these equal to 0. Right here, I'm going to subtract the 8. So that's going to give us that -8. And here we'll positive 2. And I'll get b is 2. Now, what answer would y'all put in MathLab on that one is the trick? Are y'all going to put both of these answers in MathLab?
You're just gonna put the 2.
I'm just going to put the 2. Remember, we can't take logs of negative numbers. So if you're doing a log equation and you get a negative answer, you got to throw it away. Because as soon as you plug that in for that b, you're going to get an error message. Okay? Remember, we was getting error messages that said non-real results and stuff like that. Okay? So only take the positive answers on number 23. All righty, now another log one coming up. So let me get this paper and write again. Hey, y'all, 24. Solve again. So this is the last of the log equations. So this one has the log base 2 of x plus 3 plus a log base 2 of x minus 3. That's going to equal a 4. So I got 2 logs on this side, but none on the right side. So watch how this one will work out. First thing, we got to write the left side as a single log. Now, y'all, these are being added. They're not being subtracted. So since they're being added, they'll look like a product instead of a quotient. So my log 2 comes down, and I'll have the x plus 3 times the x minus 3, and then all that'll equal 4. And what we're going to do now is actually multiply that product there, okay? So bring down your log 2. Now, these are conjugate pairs, so I'm going to shortcut. I'm going to do x times x and get an x squared. 3 times -3 is a -9. All equal to 4. So remember, conjugate pairs, I don't have to FOIL out everything because this 3x and that -3x are going to cancel anyway, okay? So shortcut on these conjugates. All right, so notice, this now looks like number 22 because 22 had a log on one side equal to a number. 23, we had logs on both sides, so we did it a little different. But y'all, I got a log on one side equal to a number. I'm going to rewrite it as exponential. So my base is the 2. My exponent is the 4. And that's going to equal the x squared minus 9. All right, so let's see. 2 times 2 is 4, times 2 is 8, times 2 is 16. So 2 to the 4th equals 16. So y'all, here's the thing on this one. I got an x squared term and a bunch of numbers. I don't have a regular x term on this one. So I don't have to factor this one technically. I can get this answer by putting all the numbers over here and doing a square root. So what I'm going to do is add the 9 to get the x squared by itself. So I get 25 equal to x squared. Now I can take square roots of both sides. So let's see. Now check this out. Since this is a log equation, I don't even care about the negative square roots of this. Remember, we were using plus or minuses on square roots. Well, on this one, I don't care about that minus because I know I can't take a negative answer. So the only number I'm worried about on that square root of 25 is a 5. Okay, so we don't have to worry about the negative 5 being an answer on this one. Okay, only that positive 5. So for question 22, 23, and 24, since they're all log equations, remember, you cannot take negative answers. All right, y'all, then the last one we got to worry about. And this one was another word problem. So let me get how that reads here. So the number of books in a small library increases according to the function. B equals 7,400 times E to the 0.02 T. So B apparently stands for books. And this equation can estimate how many books are in this library after ever how many years went by. Okay, and T is measured in years. So what they want to know is how many books after 3 years. So y'all, all we got to do is put a 3 in for that T, throw that in our calculator and see what we get. So we're actually going to put in 7,400 E to the 0.02 times 3. Now, y'all, I'm going to write down 4 answers and see which one y'all get. So I got 788.58 for A. B, I got 9,042. C, I got 8,496. And then D, I got 20,819. So if any of y'all got a calculator, punch that in and see what you get. And see if we're going to go with A, B, C, or D. And then I'm going to be punching that on mine while y'all are doing y'all's. So 7,400. Now to get to E with the exponent, I want to hit second LN. And then we had 0.02 times RT, which was 3 years. Now we're going to round this to the nearest book. Okay, y'all. So let's see. We're going to hit enter.
It's gonna be 78.58.
There you go.
758.
So that'd be my A that I had. So 78.58. Good job. So yeah, I like that one. It's always multiple choice. You're going to see a few of these are multiple choice in here. But y'all, this number 25, this question is on the final exam also. So this one's not bad to me, just putting in whatever number they give you for that T, solving it and being done. Alrighty, so y'all, let me show y'all what we got going on now. So that's test 4 review. Now, for test 4 bonus, what I'm doing for the test 4 bonus, y'all have a support assessment diagnostic in your homework. It opened up yesterday. It should say support assessment quiz. So we got to do it anyway because it's for the support class, but it does not count toward the grade at all. Okay, you got to do it, but it don't count toward the grade. So since it don't count toward the grade, what I'm doing to inspire y'all to maybe do better on it, I'm going to use this support assessment quiz as your bonus for test 4. Now this thing has I think it's 10 questions. And it's out of the support work. So it's not bad. It's just pretty simple, 10 questions. We just got to do an assessment for every class technically. So we use this for our support part. But like I said, it's not going to count towards your grade. It's only going to count towards your bonus if you do it, okay? Well, technically you got to do it, but this will inspire you to maybe do better since it don't count against you. All right, Wednesday, I mean, not Wednesday. Ooh, I'm on the wrong day. Thursday for y'all. Y'all, Thursday, we're going to review final exam. And Thursday is technically our last class. So that'll be our last Zoom class. Now, next Tuesday. Technically, we don't have a class next Tuesday. It's what we call a student study day. But I will use next Tuesday. I will log on. And if anybody needs help with anything on that final exam review, I'll use Tuesday to fix you up. So we'll make Tuesday optional. If you need any extra help, come that Tuesday and we'll help you then, okay? But yeah, technically our last class, as far as getting any notes and stuff, will be Thursday when we do the final exam. Now, the final exam itself, the final exam will open on Wednesday, December 6th. So the earliest I can open it is on Wednesday, December 6th, and it'll be due by December 10th. So you have the 6th, 7th, 8th, 9th. So 5 days you have to get that final exam done, okay? Now, after Sunday the 10th, starting that Monday, I'll figure out final grades. I'll drop low tests and do all that fun stuff so that I can get you pretty aware of what your grade's going to be, okay?
On the for the final exam, you know how on the regular test how we had to do the review and make like a 90 or above before we went to the actual test. We won't have to do that on the final exam, will we?
No.
Okay.
No.
Okay.
No. So, and it's all multiple choice, so you don't have to struggle with trying to put answers in also.
Oh, okay. Perfect.
Yeah, it'll just be A, B, C, D, and roll on to it, okay?
So next Tuesday class is optional.
Yeah, so I use it like some people after Thursday might still be confused about the ladder leaning on the wall or something like that. So if you have any final questions that are bugging you, we'll use that Tuesday morning to get y'all fixed, okay?
Okay, cool. Thank you, Mr. Rathfun. I'll see you Thursday.
Alrighty, y'all. So I'm gonna stop my recording and I'll get this out in about